In the last module, you learned about an element of melody called pitch. You learned the symbols that indicate whether a pitch is high or low, such as the staff and clefs. These symbols were added to your understanding of musical language. A language is a systematic means of communicating ideas or feelings by the use of conventionalized signs, sounds, gestures, or marks having understood meanings. These opening modules help you to learn the language of music, including all of its conventional symbols. Musical language allows anyone to sit down to a piece of music and recreate a performance of that piece as the original composer intended. This module explains the conventional symbols for duration. Duration is the length of time that a pitch or silence occurs. The unit of measurement that we use to describe duration is a beat. The beat is the steady underlying pulse in music. It is the thing that you tap your foot to when you hear music. It is what a conductor shows with their hands or baton. A beat can be slow, fast, or somewhere in between. How fast the beat occurs is known as tempo. The idea of tempo is arbitrary, but since as early as the 1st century, musicians and scientists alike began experimenting with ways to show the beat and to present it regularly. The first patented mechanical device for keeping a beat was invented by German inventor Johann Meisel. He called it a metronome. His device kept a regular beat and could be adjusted to any desired tempo. The version of his metronome from the 1820s, the last in a long line of iterations, has remained mostly unchanged to this day. Because of Beethoven's interaction with Meisel in the early 19th century, the metronome gained popularity. Whenever you see the term MM on a musical score followed by a numerical tempo marking, it means Meisel's metronome. Today, you can still purchase a Clockwork Metronome that is basically the same design as Meisel's. However, many of us opt for a more cost-effective digital version. The indication MM is often followed by a note value and a number that indicates the tempo. For example, MM half note equals 80. The number represents a numerical indication of how tempo is measured. Tempo is measured in beats per minute, or BPM for short. A metronome's tempo typically is adjustable from 40 to 208 beats per minute. Now that you have learned the concepts of beat and tempo, we can learn how these concepts are notated on the staff. The remainder of this module will focus only on the notation of duration. Duration is notated using note heads with the addition of other symbols. A note head with 2 vertical lines on either side is known as a double whole note. It is the note with the longest duration in Western music notation. A double whole note has a value of 8 beats, or 8 foot taps. Given a beat, a pitch that has a duration of 1 double whole note would sound like this. A whole note is a note head without the lines on either side. It is half of the value of a double whole note. Therefore, a whole note has a value of 4 beats, or 4 foot taps. A pitch that has a duration of 1 whole note would sound like this. To determine the remainder of the most common notation symbols for duration, it is best to think in terms of fractions. you will quickly learn that many of the concepts of music have mathematical definitions or can be described through mathematical analogies. In fact, to be a musician is to have an understanding of not only music, but also math, physics, biology, engineering, history, and every other subject. For instance, Meisel's metronome would not be possible without the knowledge of physics. His invention uses an upside-down pendulum. To follow the rabbit hole to completely understand Meisel's invention, we have to have a knowledge of kinetic and potential energy, gravity, and how varying weights and lengths of the pendulum parts affect its motion. The remaining note values can all be related back to the whole note. It is called a whole note because the other duration values that we learn will be named by the number of times you have to multiply them to get back to the whole note value of 4 beats. The shorter duration values represent parts of the whole. We can think of a whole note as the value that fits in a whole pie chart, and the smaller values will represent varying divisions or percentages of the pie chart. A half note is a note that is 1/2 the duration of a whole note. A whole note lasts 4 beats. Therefore, a half note lasts for 2 beats. There are 2 half notes in the value of 1 whole note. To notate a half note, you must add a stem to the note head. A stem is a vertical line that attaches to the note head. A pitch that has a duration of 1/2 note would sound like this. A brief side note on how we speak about the beat values for durations. We often say that a note gets a certain number of beats. So instead of saying a half note has a duration of 2 beats, it is common to instead say that a half note gets 2 beats. A quarter note is a note that has 1/4 the duration of a whole note. Therefore, a quarter note gets 1 beat. There are 4 quarter notes in the value of 1 whole note. To notate a quarter note, you not only add a stem to the note head, you also fill in the note head. A pitch that has a duration of 1 quarter note would sound like this. An eighth note is a note that is 1/8 the duration of a whole note. There are 8 eighth notes in the value of 1 whole note. To notate an eighth note, you fill in the note head, add a stem, and then add a flag to the end of the stem. A flag is the mark added to a note stem to indicate the beat division of that note. A flag added to any note will cut the duration of that note in half. So, in this example, we added a flag to a quarter note. A quarter note gets 1 beat. When we add the flag, we cut that value in half, or 1 divided by 2 equals half. Therefore, an eighth note gets 1/2 of a beat. Because of the use and definition of the flag, from this point on, we will relate each smaller duration to both the whole note pie chart and the amount or fraction of a single beat that it gets. A pitch that has a duration of 1/8 note would sound like this. A 16th note is a note that is 1/16 the duration of a whole note. There are 16 16th notes in the value of a whole note. To notate a 16th note, you add an extra flag to the 8th note, cutting its value in half. Therefore, a 16th note gets 1/4 of a beat. A pitch that has a duration of 1/16 note would sound like this. A 32nd note is a note that is 1/32 of the duration of a whole note. There are 32 32nd notes in the value of 1 whole note. To notate a 32nd note, you add an extra flag to the 16th note, cutting its value in half. Therefore, a 32nd note gets 1/8 of a beat. A pitch that has a duration of 1/32 note would sound like this. You might be thinking to yourself, we can't possibly get any shorter than that. Well, you're wrong. There are 3 more subdivisions of the whole note that have occurred throughout history in musical notation. The next, the 64th note, is most commonly the shortest notated duration. The 64th note is a note that is 1/64th the duration of a whole note. To notate a 64th note, you add an extra flag to the 32nd note. Therefore, a 64th note gets 1/16th of a beat. The next two values have occurred in published music but are rare indeed. The 128th note is a note that is 1/128th the duration of a whole note. To notate a 128th note, you add an extra flag to the 64th note, cutting its value in half. Therefore, a 128th note gets 1/32nd of a beat. The 256th note is a note that is 1/256th the duration of a whole note. To notate a 256th note, you add an extra flag to the 128th note. Therefore, a 256th note gets 1/64th of a beat. At this point, you may be thinking that this many note values is unreasonable, but they all have come to be because the notational system and the composers using that system demanded a need and then replicated the need for these various duration values. Keep in mind that based on the speed of the beat, these values can be augmented or diminished to sound longer or shorter. For instance, quarter notes at 60 beats per minute sound like this. And quarter notes at 120 beats per minute sound like this. For each duration value, for the sounding of a pitch, there is an equivalent symbol to notate that duration value of silence. Silences in music are known as rests. Rests have duration, just as pitches have duration. The equivalent symbols for each value look like this. A double whole rest looks like a stubby tall rectangle. A whole rest looks like a doffed top hat. A half rest looks like a top hat that is still on a person's head. These two symbols are very similar, so sometimes it is hard to remember which one represents the whole rest and which one represents the half rest. A good way to remember them is to think that a whole gentleman would take off or doff his hat out of respect to another individual. A half a gentleman would leave his hat on. A quarter rest is quite different. It's kind of squiggly. The rest has had many permutations since the beginning of musical notation. This is what the current evolution of the rest looks like. An eighth rest looks like this. From here on, we can notate the smaller value rests in a similar manner to the smaller value pitches. For a 16th rest, you add one more line with a dot to the 8th rest. The same goes for the remaining rest values. One final way to look at all of these various duration notations is to consider them in the same manner of a term from nuclear physics, the half-life. In nuclear physics, a half-life describes how long it takes for half of a radioactive substance to decay and become disintegrated. In this analogy, the radioactive substance is the double whole note. Each smaller duration is equal to 1/2 of the previous duration. We can use this idea to show how we have started with the largest duration value, the double whole note, and how the act of continually cutting it in half created the remainder of the duration values. Theoretically, we could continue cutting note values in half to infinity, although at some point the change in duration becomes inaudible to the human ear. Before wrapping up this module, there are a few more conventional symbols for duration to learn: the dot, the double dot, and the tie. A dot added to the right of a note head lengthens the value of the note by half again its value. This requires some more musical math. Let's use a whole note as an example. A whole note gets 4 beats. Now let's add a dot to the right of the whole note. The dot means that when reading this duration, we should perform it for its regular duration plus another half of its regular duration. Its regular duration is 4. Half of its regular duration is 2. 4 plus 2 equals 6. That means that a dotted whole note gets a total of 6 beats. How about a quarter note? If we add a dot to a quarter note, we have to perform it for 1.5 beats. That is, its regular duration of 1 beat plus half of its regular duration, or half. Both note heads and rests can be dotted. A double dot works with the same half-life principle described earlier. Each additional dot added to a note or rest adds half the value of the previous dot. For example, let's double dot a whole note. The first dot added half the value back to the note being played. A second dot adds another half of the half, or a quarter, of the value back to the note being played. A whole note gets 4 beats. Adding the first dot added 2 beats, or half the value. Adding the second dot adds an additional 1 beat, or a quarter of the original note's value. So a doubly dotted whole note gets 4 plus 2 plus 1, or 7 beats. A doubly dotted quarter note would get 1 plus a half plus a quarter, or 1 3/4 beats. A tie is the musical equivalent of a plus sign. If 2 notes of the same pitch are tied together with a curved line, it means that the notes should be performed without a pause or break in between them. If we tie 2 whole notes together, we add both of their durations of 4 beats together. 4 plus 4 equals 8. Therefore, 2 whole notes of the same pitch tied together would get 8 beats. 2 quarter notes of the same pitch tied together would get 1 plus 1, or 2 beats. Practice writing all of the notation that you've learned in this unit. Having carefully crafted musical notation means that anyone who reads your music will be able to instantly read and perform it.